Welcome to 9.3 Properties of Logarithms. So we have a basic idea of what logarithms are. Now we're going to start solving equations and using different properties to simplify expressions. Our first property that we're going to use is what we call the multiplication property. What the multiplication property says is if we have a logarithm of two items that are multiplied together. So here it's m and n. What we can do is we can rewrite this as log with the same base, and I'm going to take the first one, m, and it's going to be added to the log of the same base, b, of n. So we're essentially taking this and we're writing it as one log that includes the m, and one log that includes the n, and we add them together. Okay, so this is going to come in handy. We can also use it the other way. So if we're given two things that have the same log with the same base, and it's any number or expression, m and n, and they're added together, then we can say this is the same as log with base b of m times n. So it goes both ways, and it's going to be important to know this, and it's going to be important to be able to use this going both ways in order to solve equations and simplify expressions. Here's an example of what one of these expressions might look like. We're looking at log base 2 of 48. When trying to simplify this, I would take 48 and I would break it into factors. So if you factored it, you would get let's see, we have 2 to the third, 2 to the third, 2 to the fourth. So we would have 2 to the fourth times 3. Okay, then I would look and see, what are you given? You're given an approximation of a log. Log base 2 of 3. So if we rewrote this as log base 2 of 2 to the fourth times 3, notice 2 to the fourth times 3 is 48. Then what we can do is we can take this one step further and say log base 2 of 2 to the fourth, and then remember that since these things are multiplied together, we can add the logs, like we use that basic multiplication property. Okay, so log base 2 of 2 to the fourth, if these two match, then they go away, and we're left with just the 4. And now we knew that log base 2 of 3 was 1.585, so we can substitute in right here. So that gives our final answer to be 5.5850. Okay, if you want to include on the last part and say log base 2 of 48 equals that, I think that's a good idea as well. Not necessarily 100% necessary on that. You can just write this number, I'm okay with that, but if you want to write that little add-in, that's always a nice little addition to it. Alright, the second one that we're going to look at is the quotient property. The quotient, just like the multiplication, takes a single logarithm and it splits it into two logarithms. So if we have a logarithm of a base of two things that are divided, then we can say it's the same as log of base b of the top one, so it's important that the top one goes first, and you subtract the log of the bottom. This goes both ways as well. If you have log same bases and they're subtracted, then we can rewrite this as a single logarithm of the top, the first one, and the bottom as the second one. Okay, so we're going to use these in a similar way that we use the multiplication. So again, we're going to use this to approximate logs. So this first one, we're given certain values, we're given certain log values, and we're trying to approximate log to the 3/4, or base 3 rather, of 4. What I usually do on this is I look at what's given, and I say, how can I get what I'm trying to find to be written as something with some operation of these other two. So we have 5, we have 20, and we're trying to find 4. So what I would rewrite this log base 3 of 4, I would rewrite it log base 3 of 20 over 5. Because 20 over 5 is 4, and they give us 20 and 5. So it kind of makes sense. So now that it's division, we can say it's log base 3 of 20 minus log base 3 of 5. That's using that same property from the last slide. And now that we know these logs, we know that log base 3 of 20 is 2.7268. And we know that log base 3 of 5 is 1.4650. We can solve it. And when we subtract these, we get 1.2618. And again, if you want to write log base 3 of 4, I think that makes it look mighty official. Okay, so that's using the quotient property. The next property that we're going to look at is what we call a power property. And what happens in the power property is you're given the logarithm of something that was raised to a power. So this p is a power, and what we can do is we can say we can represent that out front. So we can say it's p times the logarithm. So the p, instead of being represented in the log, is actually pulled out front and it's multiplied by this entire log. It also works the same way. We can put the p with the m. So we can rewrite this with the p as a part of the logarithm. Okay, so that power can be either represented out front or it can be represented inside the logarithm. So given log base 4 of 6, that's what we're given, we're trying to find this value. So I would start with that value, and again I'd ask myself, how are these kind of related? How can I use what's given to get here? 36 and 6 makes sense to say, let's rewrite it as 6 squared. And when I rewrite it as 6 squared, using that power rule, I can take this guy and I can say I'm going to represent it out front. So it's going to be 2 log of 4, and that's or log base 4 of 6. We know log base 4 of 6 is 1.2925, and it's 2 times that. So when I do that multiplication, you end up with 2.5850. And again, I'm going to do it log base 4 of 36 equals that. Okay, so we use these properties to manipulate, and we kind of see how they're related, and by manipulating it, we get it to be where we can use something that's given. And that's our ultimate goal, is we want to simplify this down, we want to find an approximate value, and actually on these, I should really be saying that this is approximately, because we don't know it's exact because we approximated our initial one. Right? When we're solving equations with logs, here's where we're really going to have to use these properties and kind of manipulate and just kind of see where it goes. The first thing that I'm going to do on this is I'm going to take this 3 and I'm going to represent it with the x. So I'm going to write this as log base 5 of x to the third minus log base 5 of 4. Okay, and my advice on this is if you can combine logarithms into a single logarithm, I would. So here we have a subtraction, so using that quotient, we can say this is log base 5 of x to the third over 4, and that equals log base 5 of 16. Now that we have 2 logs that are set equal to each other, their values inside of the logs must be also equal to each other. So x to the third over 4 is equal to 16. X to the third is equal to 64 by multiplying both sides by 4. And then taking the cubic root of both sides, we get x is equal to 4. I would suggest plugging this back in to make sure that it works. Okay, just to make sure that you did it correctly. Right? Again, with that philosophy of if you can combine 2 logarithms into a single logarithm, I would every single time. So since this is addition, I can rewrite it as log base 4 of the 2 items multiplied together. So it's going to be x times x minus 6. And that's going to equal 2. So really what we're saying is log base 4 of x squared minus 6x is equal to 2. Now if you remember, if we have log set equal to a number, what we can do is we can take 4 squared and set that equal to whatever the logarithm was. So that's using items from 9.1 and 9.2. And now if we have an x squared, we want to get everything to one side and set it equal to 0. So by subtracting 16 from both sides, we get x squared minus 6x minus 16. Okay, factoring it out, we get x plus 2 and x minus 8. Setting each factor equal to 0, we get x minus 2 and positive 8. Something that we always want to do on this when we solve equations is we always want to plug this back in to make sure that we are taking a log of a positive number. Okay, we cannot take logs of negative numbers without getting imaginary solutions. We're looking for real solutions here. So when you plug negative 2 back in, we'd take log of negative 2, and that gives us an imaginary solution. So we're actually going to say that's not one of our solutions, but we can do log of 8, and that is a solution. Okay, so make sure that you keep in mind that log always has to be a positive number. It cannot be a negative. We'll move on to section 9.4. This one's really going to focus in on using our calculator more to help us. So what we can do is we can do log of 3 or log of 0.2. And really what this means, if there's not a base written, we're used to seeing it as a base. If there's not a base written, it's really base 10. So anytime we have a base 10 of a number, then we can just plug this into our calculator. So you're going to find a log button on your calculator, and you're really just going to hit that button and then hit 3 and hit enter. And when you do so, you should get 0.4771. Okay, and if we plug in log of 0.2, you should get negative. And again, I'm rounding these. So rounding correctly, usually we take these to 4 decimals. Okay, that might be something you want to note. But again, just work on hitting it in your calculator. And again, that's log base 10 if it's not written. And you're going to see why we're going to be able to use this a lot more here in a minute. So using logs to solve equations, we can do the log of both sides. So if we're given this, we can say we're going to take the log of this side. We're also going to take the log of the right side. So what we do to one side, we have to do to the other. So taking this, we would say we'd move this x out to the front. It's log 3 equals log of 11 still. And now if we divide both sides by log 3, we get x is equal to log 11 over log 3. And approximating that, we would say that's approximately equal to 2.1828. Okay, so we can do the log of both sides as long as we do it to both sides. So the type of problem that you'll see that you'll want to do this on is when it's like 3 raised to an x, or 4 raised to an x, or 4 raised to a 2x, something like that. Those are the types of problems that you're going to want to use this on. We can solve a similar problem. We can just add 4 to both sides. Okay, so we want to isolate the number that's being raised to the power, and that equals 15, and we do a similar process that we did on the last one. We do the log of both sides, and when we do, we can take that x, move it out front. So we have x log of 4, log of 15, and we end up with x being equal to the log of 15 over the log of 4, and that approximates 1.9534. Okay, so we use the log of both sides to isolate this x value. So here the step I didn't include was dividing by log of 4. Okay, so it really comes down to being good at solving equations. If you want, make sure you check out the next video. It's the change of base. It is part of the homework, and we'll continue this conversation.